Hello, and welcome to another episode of Real World Analytics, or What Schools Don't Teach You. This is the second installment of my second Kaggle series. I've done one of the more conventional Kaggle competitions where it's a house price prediction and whoever has the lowest root mean squared error wins. This is an ongoing competition. It's mainly to look at advanced regression techniques. And if you've watched my previous video on this, I've decided to write two kernels, one with a more technical lean and the other one with a more business lean. I was going to split this into different parts and talk about the different parts of building it, but actually the technical one is quick. I finished it already. I'll put a link to the kernel in the description below. If you want to go have a look through it, if you hit the pause button, I'll wait for as long as you like. So you may wonder why I'm laughing. Well, I'll put a copy of it here. I had every intention of writing this with a serious tone because I want to demonstrate the difference in writing things for clients as a professional data scientist, but in the end, this is off work. This is for fun. There's no real incentives if you win this Kaggle competition because it's ongoing. And in the end, my playful streak took over, and so I wouldn't normally have pictures of Dick Dastardly in my reports to clients, but well, alas, there he is. So I want to spend some time going through the different parts of this and why I think this is a good setup for a good template to use if you're going to be doing data science consultant work. Of course, maybe without the animated GIFs. So let's go through it. First of all, I have an executive summary. If you go and look at a lot of the Kaggle kernels, they don't have this. And this is what I think really is the first step to writing something as a data science consultant. Now, again, maybe I wouldn't have the animated GIF there, but something I would have is a final impact. So here I've written that the reduction in root mean squared error is 70%, which is pretty good. And that might seem backward to you, that normally you talk about what you've done and then you conclude with, and this reduces the root mean squared error by 70%, but you need to put that up front. Something else I would like to have here is a dollar estimate. Now this is going to be particular to the company that I'm working for, that this better model, how much money is it going to save them? And even if it's not money per se, I do need to have the final impact. So what's it going to do for customer retention? What's it going to do to increase numbers of customers? What's it going to do for brand awareness? I need to put the final metric here in this executive summary. So let's go down through this. I've got an introduction. I've got the things that help with the introduction, so I'm going to explicitly call out the scope, both in scope and out of scope. I'm going to provide implementation instructions, including test cases, conceptual monitoring, again, including test cases, and animated GIFs. Well, okay, maybe not animated GIFs, but Brock and I kind of agree, like, whatever. We should have fun doing this. Starting off with the scope. Now, the scope is interesting because I have in scope and out of scope. And the first time I saw this, I thought, well, what am I doing? If it's not in scope, then it's out of scope. Isn't this kind of redundant? Well, not really, because if you look, I have 4 things in scope and 4 things out of scope. And what I'm trying to say is I'll do this, but not that. So, for example, I say that I'm going to use the data provided by the Kaggle competition, and I'm not going to bring in any external data. So that gives me this nice pairing so that if someone asks, well, what about macroeconomic factors? What does interest rate have to do with it? None of those variables are in that Kaggle data set. And I have the out of scope section there to say, I'm not going to go look for them and bring them in. I do point out that this is kind of to try to prevent arguments or conflict, because if you go with this scope to a client and they agree, later on they might say, well, wait a minute, surely economics has something to play with this. Don't you want to include that? And you can go back and say, well, I could, but we agreed previously not to. And most of the time people say, oh yeah, okay, that's right, fine. There are the rare events where someone says, no, this is important and I need that variable included. And you can point to the out of scope and you can point to emails saying, yes, everyone agrees. But at the end of the day, one of the skills you're going to need in real world analytics is the ability to have this discussion without just kind of shrugging and pointing at the out of scope and said, what, I told you I wasn't going to do this. Why are you asking me to do it? I don't understand. The way to do that is a skill you're going to need to learn. So if I get into building the model, it's another one of these things that it's one line in R. You run the SVM. There are some options you need to set. The cost, I looked at another kernel and 3 was the best. And so I have this GIF of, well, that can't be it. Like, Where's the rest of it? This machine learning is supposed to be really complicated. What do you mean it's one line? And in R, this is true for a lot of things. If you load the appropriate package, fitting a neural network is one line. If you load the appropriate package, fitting a decision tree is one line. And the real kind of difficulty is, okay, which one am I going to use? I picked support vector machines because I used them 15 years ago, and I'd like to get more in practice. But it can be a bit anticlimactic when you go to the client and you're like, yes, I'm going to do all the fancy machine learning. Okay, now, managing that expectation can also be fun. So with the technical bit out of the way, it's time to start using the model. And again, using R, there's a predict function that you build the model, and that's a model object. Use that model object and new data to generate predictions. And it's a line of code. And this is where I've dumped out the data to use for the Kaggle submission. That got me in the top 1,000, which is pretty good. So getting on into the recommendations, and again, if you go look at Kaggle kernels, you normally won't find these types of information. But if I were doing this as a data science consultant, I would definitely want to include these parts. So there's two things here. There's implementation and monitoring. So when I go to implement this, I've picked a random sample. So here I have 10 IDs from my training data, and this is the predicted value. So that when I hand this over to the production team, they can say, okay, let's verify that everything's been implemented correctly. Now, if I'm running production R, this is easy. I just hand them the model object and I'm done. But what if they're not using R? Well, what else can I do? It turns out there's a write function for this SVM package. So you can output all the coefficients of your support vector machine into text files, and then the authors have a software package called LIBSVM, and you could go and get that and install it and run from there. But then you have the question of, well, you're going to be installing kind of external software in your production system. You can't always just do that. So if I wanted to go back to first principles and get the information here, I can write down the equations, but there's the question of, okay, well, where in this model object are all the bits I need? And I don't know. It would take me a little while to go in and extract all the necessary information. And so here I'm a bit embarrassed because I say that it's important to have implementation instructions, because in R, sure, you just build the object, you use the object to predict, and you're done. If they're not using R, what do you want to do? And there's quite a bit of discussion I've seen on LinkedIn for people in software saying, okay, you guys, you data scientists are building all these nice models, but we can't implement them. And here I am saying, be careful, there's a trap. You need to be sure you can implement your models. But actually, I've fallen into the trap myself because I really don't know how to extract all this stuff from this. And I don't really want to spend the time right now to do that. So it's just a bit awkward. Really? So this kind of proves my point that it's important, because otherwise, what do? My model would die here without either production R or this LibSVM package and testing it. But then let's talk about monitoring, shall we? So even if you do get it implemented, the idea I have here is that the sample submission was based on a model. I've reproduced that model. It's a linear model. Again, building the model is one line. Generating predictions is one line using that model object. It's a pattern. And then I want to say, well, how would my model have worked retrospectively in time? So here I have that linear model in the support vector machine. Purple, you can see the support vector machine does better than the linear model. That's good. Continuing on a theme, there are test cases of here's some certain dates, here's the number of houses for those dates, here's the linear model and the support vector machine and their root mean squared error. I do the same thing with the residuals. So if I look at the overall data, is the support vector machine providing better estimates? Looking at the log of the ratio between predicted and actual. So 0 is where things should be centered. And you can see the purple, again, the support vector machine is quite narrow. So on average, it's much closer than the linear model. Continuing on a theme, here's some random IDs with the predicted house prices from the previous one, and then the error, the log of the ratio, so that you can, again, verify that this monitoring has been implemented correctly. Ideally, all this monitoring would fit into an existing framework for monitoring models. just not always an existing framework, unfortunately. And then finally concluding, I decided to have animated GIFs in this, and I do think you should be having fun. And it is a great feeling if everything is implemented and everything's monitoring. And that way your client knows that the model they have in is working and they can start seeing the benefits, and it's worth celebrating. And if you are doing all this stuff outside of your normal work hours, if you're just learning and you can't celebrate and have fun when you're finishing it, I encourage you to try. I've decided to kind of make that my shtick on Kaggle, is to write things that are fun so that when people read it, it's not all just serious math and building graphs. You should have fun with this stuff. So do you have a template? Is there something that you enjoy including or excluding, or something that you think I've missed, or something that looks really important to you and you want to try out? I encourage you to download this or another kernel and sit down with your manager and start going through at least the templates and really discuss what type of information is needed, what should be excluded, and everything else. If you let me know in the comments below, I'd really appreciate it. Thank you all for watching, and I'll see you next time on Real World Analytics, What Schools Don't Teach You. Goodbye.